Okay, so the very last section here is going to be adding and subtracting and multiplying radical expressions. Hopefully it won't be too incredibly horrible. Alright, this is definitely one of the easier sections of this unit. Okay, so if I'm adding and subtracting, the most important part is that I have to have like radicals, right? So radicals with the same root and the same base are like radicals. So everything under the radical is the same and the root has to be the same. Okay, so just like 3x and negative 5x are like terms, 3 root x and negative 5 root x are like radicals. And if you think about changing these two rational exponents, this would be 3x to the 1/2, this would be negative 5x to the 1/2, right? So they really do have the same exponents. Remember, that was the important part about being like terms. Same variable, same exponent. Same thing with radicals, right? Same variable, same exponent. Okay, so the question is are those like radicals? The answer, of course, is going to be no. They have different roots. All right, one is a square, one is a cube. That doesn't work. They have different roots. Okay, so when you decide that they are like radicals, they add together just like terms do, right? 3x and 2x makes 5x. 3 root x plus 2 root x makes 5 root x. Okay, you just add the coefficient in front. The radicals themselves do not change whatsoever. Even if they're numbers, it doesn't make a difference, right? So 4 root 11 plus 8 square root 11 makes 12 square root 11s, right? You're just like counting the number of radicals that exist there. 5 cubed root 3x minus 7 cubed root 3x makes negative 2 cubed root 3x. Root stays the same, base stays the same. Okay, only the coefficient out front is changing. Okay, here, can't do it. Okay, there's a square root and a cubed root. Those are not like radicals, so you can't add them. So that's just your answer. Okay, square root, cubed root, not the same. Now on these, before I can decide if they're like radicals, I need to simplify them as far as I possibly can. Okay, so we've already done this back in 10.3 and 10.1, right? So you break these things down. Groups of 2 because it's a square root. Leftovers stay inside, so 2 root 5. Do the same thing here. 9 times 5, 3 and 3. Don't forget the 2 that's out front. The 3 comes out to join it. Got a 5 left in the radical. So 2 root 5 plus 6 root 5 would give me 8 square root 5. Okay? Adding up the radicals. So only if they are like radicals. We don't care if the number in front is the same, but the radicals themselves have to be identical. Okay? So same thing here. Here we go. So I've got 9 times 6, 3 and 3 and 3 and 2, groups of 3. So 3 on the outside, cubed root of 2 left inside. Okay, the 16 would be 8 and 2, 4 and 2, 2 and 2. Groups of 3. There's a 5 out there. Let me move this stuff down. 3 cubed root 2. I didn't leave myself a lot of room. Alright, so the 2 would come outside, but I have a 5 out there already. The 2 will come out and multiply it by it, and then I have a 2 left over, so I get a cubed root of 2. Okay, here there's nothing I can take out. It's just a cubed root of 2. So you just leave it as the cubed root of 2. So then I've got 3 cubed root 2's minus 10 cubed root 2's plus 1 cubed root 2, right? If there's no number out front, it's always a 1. If you need to write the 1 there, that's fine. It doesn't matter. Okay, left to right with our order of operations, 3 minus 10 makes negative 7 cubed root 2 plus 1 cubed root 2, which gives me negative 6 cubed root 2's. Alright, negative 7 positive 1 is negative 6. Okay, that's all you're really doing on these. So one more just so you can kind of make sure we've got it. 6 and 8, 2 and 3, 4 and 2, 2 and 2. Right, groups of 3 again, 1, 2, 3. Okay, so the 2 will come outside. Okay, I'm going to leave myself some room to do the y here in a second. Careful with this. I've got 2 numbers left over. Remember to multiply them back together and put them back underneath because it's still not a group of 3. Right, I got 1, 2, and 1, 3. So 2 times 3 gives me 6. Okay, and then for the variable, 3 goes into 4 once with a remainder of 1. Alright, 3 into 4 once with a remainder of 1. Again, if you need to, you can always write these out. 1, 2, 3, 4, and I got one group of 3's with 1 left over. Okay, here, the 6 breaks into 2 and 3. There's no group of 3 there, so it's going to stay in. I'll leave myself some room. Right? 3 goes into 4 once, so I can take a y out, and there would be 1 left over. So when you're doing these, keep in mind that the variable out front must also match, right? So the whole radical plus the variable have to all be the same. So like if this came out to be y squared, those are not like terms, you would not be able to add them. Okay, but since they have y cubed root 6y, y cubed root 6y, I can add them together. 2 plus 1, right, there's always that imaginary 1 there. 2 plus 1 gives me 3y cubed root 6y. Okay, so now the very last little part there is multiplying. So the multiplying is real simple. Okay, it's just like the multiplication from the polynomials, right? So if I have a single term out front, we're going to distribute into each term inside. The important part about multiplying the radicals is that insides multiply together and outsides multiply together. Okay, so what I mean by that is if it is underneath a radical, it will multiply together. If it is outside of a radical, those numbers will multiply together. If you're multiplying an outside by an inside, they kind of multiply like x times y does. It just becomes xy, right? So this just becomes 5 square root 3. Okay, because there's one is outside, one is inside, so you can't really multiply them together other than to just write it as, this means 5 times the square root of 3. That's all you can do. Okay, but when I multiply the square root of 3 times 30, that I can multiply because they're both under radicals and they have the same root, so 3 times 30 makes 90. All right, break that down. 3 and 3, 2 and 5. All right, so that would give me 5 square root of 3 plus 3 square root of, multiply those back together, 10. Okay, now those are not like radicals, so there's nothing else I can do. Okay, if these were both like square root of 3s, then I would add them together. If they were both square root of 10s, I could add them together. These are different, so I can't do that. Okay, so do the same thing on B. This is a square, there's a minus inside, so you cannot just distribute that exponent, right? Remember, you have to write it out side by side. So 4 root 3 minus 1 times 4 root 3 minus 1. If there was no plus or minus in here, then I would be able to just distribute that exponent. But since I have minus in there, I have to actually write it out side by side, and this is going to be a FOIL, right, because it's 2 terms times 2 terms. So the first one's together. So multiply the outside stuff, so 4 times 4 is 16, and then the inside stuff, 3 times 3 makes 9. Okay, now outside. 4 times negative 1 is negative 4, okay, and there's just a root 3 because there's nothing else to multiply with it. Inside, negative 1 times 4 is negative 4, again, nothing to multiply with the root 3. And negative 1 times negative 1 makes positive 1. Okay, do not leave it like that, though. Make sure you actually go through and simplify all of that, right? The square root of 9 is 3, so I get 16 times 3. These are like radicals, right? Square root of 3 and square root of 3, so negative 4 makes negative 8, square root of 3's. 16 times 3 is 48. And then I've got 48 plus 1 is 49. So final answer would be 49 minus 8 square root 3. Okay, so same thing here. FOIL. Right? 2 times 2 is 4, and x times x is x squared. Outside stuff, inside stuff. Okay? 2 times 1 is 2. X times 5 is 5x. Outside stuff, inside stuff. Negative 1 times 2 is negative 2. 5 times x is 5x. And last, negative times positive makes negative. 5 times 5 makes 25. Simplify each of your radicals. Square root of x squared is x. Right? Positive 2, negative 2 root 5x, those are like radicals and they're opposites, so they cancel. And square root of 25 is just 5. Okay, just 2 more just to make sure we've kind of got this. So first, okay, 21 square root of 5x. Outside, 7 square root of 5. Inside, negative 3 square root 6x. Last, negative square root of 6. Right, because negative 1 times 1 is just 1, or negative 1 and then root 6. And then nothing simplifies, right? The only thing that even breaks down is 2 and 3, but I don't have a group of 2's. Okay, nothing is like radicals, so that's just my answer. And it'll happen. They'll just be big, ugly answers sometimes. Okay, and then this very last one, here we go. So I can't square because there's a plus in there, so we're going to write it out side by side. Now the thing that's different about this one is this guy. So I said usually plus and minus signs separate terms, right? But since this whole thing is under one big radical, we kind of count that as one big term, and that is your second term. That's one term, that's your second term. So when I FOIL, right, my first would be the square root of x minus 3 times the square root of x minus 3, which since I'm multiplying x minus 3 by itself, I'm just going to write it as x minus 3 squared. So I'm multiplying that by itself underneath the radical. Okay? And we do that so that those will cancel out here in a second. Okay, square root of x minus 3 times 5. 5 is outside. All that stuff is inside. And 5 is outside. The rest of that stuff is inside. And 5 times 5 is 25. Okay, so here the square root of x minus 3 squared, remember with the root and the exponent are the same, they just kind of counteract each other. You get x minus 3, right? Like radicals, so 5 plus 5 makes 10, square root of x minus 3, and then plus 25. Okay, so combining like terms, we've got the negative 3 and the positive 25. Be careful here, a lot of people try to put these two together. Okay, but this 10 goes with the square root of x minus 3. This is 10 times square root of x minus 3. So in order to add this to something, I would have to have another x minus 3 like I did up here. Okay, so be careful there, don't put the 10 with the negative 3. Okay, but the negative 3 and the positive 25, those are allowed to go together. X plus 10, square root of x minus 3, plus 22. Okay, so that's adding, subtracting, multiplying, okay, radical expressions. That is the end of that unit. Good luck with that.